Now, in this question, we want to determine the limiting reactant and the mass in grams of the nitrogen that can be formed from 50 grams of N2O4 and 45 grams of N2H4. And the way we know this is going to be a limiting reactant problem, even if they didn't tell us, is because we have two different chemicals right here that are going to be reactants. And when we have two different reactants and two different amounts, like we have this 50 here and this 45 right here, one of those reactants is going to run out first. And the one that runs out first is going to be called the limiting reactant because it limits how much product we can make over here. And the other reactant will be in excess, and the one that's going to be in excess, we're going to have some of that left over. And so the way we're going to figure out the limiting reactant is basically we're going to see how much of this chemical right here can produce products and how much of this reactant over here can produce products. So we basically have to do this problem basically twice. And so what I'm going to do is I'm going to take this 50 grams of the N2O4 right here, and I'm going to put that right here. I'm going to say we got 50 grams of this N2O4, and then for this chemical right here, the N2H4, I'm going to say we have 45 grams of this one right here. So I'm going to put 45 grams, and I like doing this because it lets me know how much of this one I've got and how much of this one I've got in units of grams and not moles, and it just helps me keep kind of everything in order. And so what I'm going to do is I'm going to do the N2O4 right here, and when I go from this chemical to, I can either go to the N2 right here, or I can go to the H2O right here. It doesn't matter which one I pick, but I'm going to pick the N2 right here just because the problem is specifically asking me how many grams of nitrogen I'm going to get. So I'm going to go to this N2 right here. And so what I'm going to do is I'm going to take the 50 grams that it gave me, and then I'm going to divide it by the molar mass because you have to be in moles if I'm going to go to this product over here. And it tells me that the N2O4, the molar mass of that is going to be right here. So I'm going to take 50 and I'm going to divide it by 92.02. And when I do that, I'm going to get 0.5433. And that will be moles of N2O4 like this. And so I convert from grams to moles by dividing by the molar mass. And that equation, if you didn't know, is going to be the mole is going to be equal to the mass in grams divided by the molar mass. So that's what I did right here. I took the amount in grams right here and divided by the molar mass, and I got this moles there. And so now what I'm going to do is I'm going to set up a dimensional analysis where I'm going to put the N2O4 on the bottom, and then I'm going to put the N2 up top like this. And from this balanced chemical reaction right here, it tells me that I have 3 for this nitrogen right here, so I'm going to put a 3 here. And then for the N2O4, there's a 1 right here, and so I'm going to put a 1 right here. And what's going to happen is this N2O4 will cancel with this N2O4, and then I'll be in N2 right here. And so when I do this number here times 3 divided by 1, I'm going to get 1.629, and this will be moles of N2 like this. And so here is the moles of the N2 that can be produced from 50 grams of N2O4. But we have this N2H4 right here, and we need to figure out how much of product this one can make right here if we have 45 grams of this one. And so I'm going to do I'll do the N2H4 here, and we got 45 grams of this chemical. And what I'll do is I'm going to divide by the molar mass, and it tells me that the molar mass is going to be right here, so it's going to be 32.05. And so when I do these two divided by each other, I'm going to get 1.4, and that will be moles of N2H4 like this. And so what I'll do from here is I'll put this over 1. So this is what I'm given, and I'll set up a different dimensional analysis here, and we'll put N2H4 on the bottom, and then I'll put N2 up top here. And the balanced chemical reaction tells me that for every 2 of these right here, for every 2 of these, I'm going to produce 3 of these. So for every 3 molecules of N2 that's going to be made, I'm going to have to use up 2 of these N2H4s. And by putting this on the bottom, this and this will cancel out. And then I'll do 1.4 times 3 divided by 2. And when I do that, I'm going to get 2.1, and that'll be moles of N2 like this. And so I have these 2 different amounts, and what I'm going to do is I'm going to compare these 2. I have this one right here, and then I have this one right here. And because this one right here is going to be smaller, this will be the limiting reactant. So I'm going to put limiting reactant. So limiting reactant will be the N2O4. And what that tells me is this is what actually ends up getting made. This right here, the 2.1 moles of N2, this could be made if we had more of this right here. That means that this one is going to be the one that's going to be in excess, meaning I have more of this than what the reaction can handle, because if I had more of this N2O4, then maybe this N2H4 would be the limiting reactant, and this would end up being made. But because this one produces the least amount, the N2O4, this is what actually ends up getting made. This is the limiting reactant. So if this right here, the 1.629 moles of N2 actually ends up being made, I need to know the mass of this in grams. And so what I'm going to do is I'm going to use this equation right here, and we're going to convert this moles to grams. And so what I'll do is I'll take 1.629. That's going to be the moles. The grams I don't know. I'm going to divide this by the molar mass. This is the moles of N2. This will be the grams of N2 I'm going to solve for, and I need the molar mass of N2, and that's going to be 28. And so when I do 28 times 1.629, I'm going to get that the amount in grams is going to be 45.612, and this will be the grams of this N2 right here. So this will be the answer for this question.